In the last lecture, we already discussed that if the differential equation is not expressible in the form of polynomial, the degree of that differential equation can't be defined. The degree is defined only if the polynomial function of derivatives can be created. In case differential equation has log, exponential, and trigonometric function of the derivatives, it is not possible to define its degree. The reason is that the highest power of log, exponential, and trigonometric terms goes to infinity, and hence the degree is not defined for them. Let's have a look at this example to understand this concept. We can find the degree of this differential equation, and that is 1, because degree is the highest power of the highest order derivative appeared in the differential equation, and here is the highest order is 1, and the power of this dy over dx is 1. Hence the degree is 1. Now in case we have x is equal to sine of dy over dx, in this case we can't find the degree if it has term like sine of dy over dx. To understand this concept, let's expand sine function by using power series, and that is sine of x is equal x minus x cube over 3 factorial plus x5 over 5 factorial is equal. We can also write in summation form, that is n is equal to 0 up to infinite of this term. Now in the case of sine of dy over dx, I mean if we replace x by dy over dx and look this equation again, then the expansion will be same, but just we need to replace x by dy over dx in each and every term now. After doing this, we will find that degree of dy over dx is increasing to infinity, and hence we can't assign any fixed value to differential equation as a degree. This basic idea about expansion of trigonometric function is applicable to log and exponential functions as well. Hence, the conclusion based on this concept is that degree is not possibly defined. The reason, when dy over dx is inside a trigonometric function or exponential function or log function,